Okay, this is the second part of the retinoscope and retinoscopy principle and all these things. Okay, so optical principle is basically optical theories initiated by Landau, 1878, to find the position of paraxial far point, punctum remotum, of the eye relative position to retinoscopy aperture. See, sometimes students get stuck in this point. Let me explain. Okay, so in the previous thing, I have shown this, isn't it? The focal plane and the knife edge. So basically, focal plane means far point. Exactly why? And position of retinoscope aperture means knife edge. So whenever you throw the parallel light, okay, whenever you throw the parallel light, so let's take an example. This is, oh, sorry, I'm very terribly bad at drawing. Whenever you throw the light and light strikes the retina and it comes out, okay, of the eye. Whenever it comes out of the eye, the coming out light, that this light from is striking from retina, it shows the nature of the eye, refractive error. Let's take if eye is emmetropic, then refracted light comes parallel. Okay, if eye is myopic, refracted light comes focus somewhere in far point. If eye is hyperopic, then light goes divergent, then virtual far point is somewhere behind. Okay, in these three cases, whenever we put our retinoscopy, let's take an example, this is retinoscope people, then the magic happens. If we put this peephole exactly at the focus, then we get neutralization. If peephole is in front of the focus point, that is far point of an eye, then we will get against the motion. And if the far point is way away to that peephole, then we go have with the motion. So that's the principle. That's what it means when it defined to find the position of paraxial far point relative to the position of retinoscope aperture. It's basically that. What do you mean by it's basically the knife edge principle. That's here we have knife edge, that is peephole, and here we have focal point. Okay, so in relation to focal point, we understand. So far point is the space point optically conjugate with the phobia when accommodation is relaxed. Basically, whenever light comes out from the retina, it shows basic nature of the eye. If myopic eye, then far point is somewhere in a space. If hyperopic, then light goes divergent, which means light goes divergent, which means far point is virtual. And if eye is emmetropic, then light goes like this parallel. Okay, that's a very important point to understand, because in relation to far point and the retinoscope peephole, we have answers for with the rule, against the rule, and neutralization. It's very important. Okay, what is working length, what is working distance reduce? Oh god, that's a good question, and it comes again and again in your viva. It's so central question. Okay, what is working lens? Lens which can stimulate infinity at a distance by placing it before the patient's eye. A power of the lens that must equal to dioptric distance from patients to examiner. It makes the retinoscope as if it is in infinity. Okay, these three things, I think you'll never understand these things. What is working lens? Okay, so let's discuss this working lens with this picture. Okay, whenever the far point of an eye is conjugate with the retinoscope aperture, just and it's just as far point is conjugate with the infinity. Working lens can move infinity up to the convenient working distance. That's the central point. Okay, what does working distance reduce? What does working lens do? It does only one thing, that is, it can move infinity or it can move, definitely not infinity, but far point of eye to the convenient working distance. Okay, let's take an example. If this is an eye and you throw the light and light strike on the retina and it comes, then let's take example, the light, if it is completely normal eye with metropia, and I know you are taking your retinoscope, this is the retinoscope, at distance of 50 centimeter from eye. Okay, what is the precondition to have neutralization? As we have already discussed, that far point of an eye, far point of this eye must be at peephole, isn't it? Must be at peephole, because peephole is by definition knife edge, and knife edge should be placed at the focus for the neutralization. Focus is what? Focus is basically far point. So in this case, patient is emmetropic, so far point is at infinity, isn't it? Now you want this far point at 50 centimeter, and just imagine which eye has far point at 50 centimeter. Answer is minus 2 diopter myopic eye. And just remember one thing, if this is a metropic eye and you put plus 2 diopter here, isn't it this whole system becomes minus 2 diopter myopic, isn't it? Because let's take an example. If consider 60 diopter is emmetropia, then isn't it 62 diopter is myopia? If whole eye's power is 6 diopter, isn't it 58 diopter is hyperopia, isn't it? So it's simple. This is eye with 60 diopter and you put plus 2 diopter, because your retinoscopy at 50 centimeter, and you know whenever you put 2 diopter plus, you make it its total 62 diopter, which is 2 diopter myopic, and the 2 diopter myopic eye has far point at peephole of the retinoscope, and then voila, we get what? We get neutralization, isn't it? Isn't it? So it's simple as that. Let's take another example, and sometimes we used to call this, isn't it? Let's take another example. Okay, let's take a few moment here. Let's take example, you throw the light and light comes out and it's parallel, and your retinoscope is at 67 centimeter. Then what is the working distance lens? It must be plus 1.5, isn't it? Because plus 1.5 diopter, putting in emmetropic condition, it means you are making eye of minus 1.5 diopter myopic, and then minus 1.5 diopter myopic has far point at 67 centimeter, and then peephole of the retinoscope matches with the far point of an eye, and then neutralization happens, isn't it? And that's what the working lens is. Working lens means, it's very important, working lens means you bring the far point at the convenient working distance. So this 1 meter with working lens, if working lens is 1 meter, then what happen if you place plano? Then far point at this, if you pen, this eye is already minus 1 diopter, isn't it, myopic? If you put plus 1, then go far point at infinity, isn't it? So if you put minus 1, then what happens? It's already minus 1, then minus 1 you add, and far point even closer, isn't it? So that's why you have to understand the concept of far point. So it's really important. What happens with the far point is, so this is the retinoscope apertures, and this is the eye. In case of hyperopia, here is the focal point, which means there is always with the rule. And what happens if far point is here between peephole of the retinoscope and the eye? It's always against the rule. And what happens if far point is away from the peephole? In case of emmetropia and low myopia, it's always with the rule, with direction, isn't it? So that's the concept. Just remember the concept. Remember two things: aperture of the retinoscope, which is definitely knife edge, and the focal point in case of knife edge principle is here, in real practical scenario, is a far point of an eye. Central important to understand these concepts. Okay, so let's discuss about origin of the fundus reflex, where fundus reflex originates. Okay, so Mildred and Leary concluded that the vitreoretinal reflex contributes the fundus reflex during retinoscopy. They concluded that vitreoretinal junction. The major ocular reflection surface is vitreoretinal interference and RP choroid and combination of there. The vitreoretinal mirror image primary source becomes secondary fundus and reflects the retinal by the retinal pigmented epithelium. Okay, the light reflects from the fundus has two components. One is a diffuse component, backscatter. Another is a direct component. Okay, two components. The effective ocular surface for visible light is at outer limiting membrane, while infrared radiation, retina and pigmented interference. So for infrared light and for visible light is two different things. Light that written from the structure is result the competition between absorption and backscattering. Hence the fundus reflects red and orange with the color. Why it is red and orange in color? Because of the competition of, because of the blood vessels, because of the blood circulation, because of choroid. Yes, definitely. So basically we come to the conclusion RP and the vitreoretinal junction is the two main sources of fundus reflex. So reflex characteristics, it's very important in case of clinical judgment, isn't it? The reflex is moving according to the refractive status of eye. That's very central important. Reflex always move according to the refractive status of eye. By observing the characteristic of moving retinal reflex, it is easy to detect refractive error such as hyperopia, myopia, and astigmatism. Okay, and we have discussed about this thing. See, it's always important if eye is emmetropic, the exiting light is always parallel. If eye is hyperopic, the exiting light is always diverge. If eye is myopic, then exiting light is always converging. That's why far point is infinity. Sorry, it's finite in case of myopic, at exactly at infinity, at plano, and beyond infinity at hyperopic. Okay. So, major reflex characteristics that we have always discussed from student to the faculty level is brightness, direction of motion, width, and speed. Brightness means dull or brighter. Direction means with the rule or against the rule. With the rule means towards which direction we are actually moving the retinoscope reflex, and the reflex from the sky shadow from the retina is also in same direction or opposite direction. Width means width of the streak is wider or is uh, thinner. Speed is in a high speed or reflex is in slow speed. Okay, so in this picture just see if it is a no movement or brighter place, because in focal point if you place the peephole of the retina, there is no movement, brightest and widest, it's always there. Okay, this is the characteristics of neutralization. But as you move away from neutralization, as you move away from neutralization, the width is becomes narrower. See, brightness becomes dull and movement speed becomes slow as you move away from the neutralization. As you move closer to the neutralization, speed becomes fast, brightness becomes bright, width becomes wide, and definitely confusing. And another thing, if focus is here, okay, focus is here, and you place retinoscope peephole here, at that point it will always be against the movement. In focus is here and you place retinoscope peephole here, it's always with. Okay, because we know Foucault's knife edge principle. Okay, fine, let's move forward. So let's talk about brightness. What do you mean by brightness? Okay, in emmetropic, it's always the brightest reflex. Low refractivity, a slightly dull, but in high refractivity, so dull. Sometimes, in case of FAK, you think it's like you cannot see even slightest of reflex. So sometimes people get confused with the media opacity, and that's not the case. You have to put either +7 or -7, and you have to put both of the lens in your hand and just see the reflex. It's the clinical standard, isn't it? So it's central important. So some conditions of the dim reflex is obviously media opacity, small pupil or darkly pigmented retinal pigment epithelium. But just remember this thing, it's far important to understand dull reflex is not a characteristics of always a characteristics of these three things. Okay, there may be high refractive error, that's why dull reflex is there. It's very important and life saving whenever you actually practice as a optometrist. Okay, why reflex is seen dull or brighter? Okay, see, this is the answer. If light coming from eye is actually parallel, then in your peephole there is a good amount of light. But when they come with a so wide divergence, there's few light comes to here. If it converges here and diverges way higher, then people gets small amount of light. That's why in case of high refractive error you have very dull reflex, but in case of neutralization you have very bright reflex. So direction of motion, it's very simple. Okay, opposite direction against the motion, always in myopia greater than 2 diopter, or far point is located between the retinoscope and object. That's the point. See, if far point is located between retinoscope aperture and the patient's eye, it's always against, no matter what. Okay, if myopia, that is more than 2 diopter. If myopia less than 2 diopter, it will be with. And the adding minus power of the lens in respective plane achieves neutralization. Okay, you means whenever you add minus lens, the far point moves away and away and away. Whenever it far point reaches at the peephole of the retinoscope, you get neutralization, isn't it? Simple. Okay, fine. So direction of the motion is, that's okay. In case of myopia, it's against. In case of, that's easy. So after reaching neutralization point, observer may move towards the patient with the motion is observed, while move away from the patient, yeah, it's against the motion observed. Or it's tricky. See, let me clear it. Okay, you did whatever it takes to get far point at the peephole. Then, as an examiner, when you move slightly ahead, then you will get what? With the with the rule motion, because far point is here and your retinoscope comes here. Now far point is away from the people, at this case you get with the rule. And if you slightly displace your retinoscope here, then far point is here and your peephole is here, you will get against the motion. It's very important clinically, and small tip that you always do. Please do this tip whenever you think you come to the neutralization point. Then just move slightly away or slightly in towards the patient. If it is towards the patient, then your reflex is with the motion. If you are slightly away from the neutralization point or away from the patient, then you will see against the motion, and then you can grossly say that yes, I'm towards, or I'm not exactly, but yes, I'm close to far point and definitely neutralization point. Yes. Speed, see, I have already told you what is speed. In case of speed, neutralization speed is infinity, and away from the neutralization it becomes slower. That's it, simple as that. Okay, the relative speed of reflex is controlled by residual emmetropic I. The residual amount of uncorrected emmetropia exists during the period of lenses and that place in the spectacle during the retinoscopy. You can always see, this is from, I think, from Boris. I just read it, yeah, and you try to understand this concept. I'll just read it. When emmetropia is more than 3 diopter, see, From the neutrality, the speed of the reflex is less than half. Very important. Emmetropy is more than 3 diopter. When far point approaches towards the aperture, wow, means neutralization. The relative speed of the reflex increases slowly. What happens? 3 times speed at only 0.5 sphere from neutrality. 6 times speed when 0.25 from the neutrality. 12 times speed increase when 0.12 diopter from neutrality, and speeds become infinity at far point. So basically, at far point, speed is infinity. As you move from far point away and away, suppose slower and slower it gets. Basically that. Okay. Don't try to remember this all these things. Okay, it's not important, not at all. How many times and okay, no, don't try to remember these things because it's not that relevant. It's just you have to remember the concepts. Okay. Width is so important in clinical setup with the patients. I always look at for the width. I don't know why I look at the width, but I love width. I do not rely on many more things, width and the direction. That's finished, because I always think like a width, and yes, in thought I always think like brightness. And believe me, I'm good at refraction, and I do refractions in very speedy manner, but it's central important width. The function of the emmetropic eye and the size of the pupil, because width basically means these two things. The neutrality fills the entire pupil. Neutrality means filling entire pupil. There is no width. Width is maximum. Okay. The narrow distance from the far point. As you move away from the neutral towards any direction, hyperopic, myopic, width becomes smaller and smaller. Okay. The broaden approach toward the far point means at the neutrality, width become larger and larger, width become broader and broader. When the residual emmetropy is 3 diopter away from the neutrality, the object sticks at about the same at pupil diameter. Okay, this is just a point. Concept is this. So width, as you know, the far point is here, and we're doing retinoscopy here. It's small, and as you approach the far point, it's getting larger, and exactly at far point. Now, voila, it fills all the things, isn't it? So same rare retinoscopic reflex. Reflex is pseudophakia, reflex is aphakia, and reflex is rare type is Caesar reflex, oblique retinal reflex, and dim retinal reflex. Okay, in pseudophakia, with the motion against the motion or mixed motion of retinal reflex appear. Examine closely, observe this reflex as a neutralize them. Mydriasis is performed to reduce the pupillary related artifact. In pseudophakia, when you throw the light, the reflection from the lens sometimes so bother you, it's really difficult to do the examination, and especially in case of if pupil is so small. In that case, sometimes it's so helpful to do mydriasis of this patient. Okay, okay, that's the concept. And in aphakia, I have already told you, in aphakia, sometimes you cannot see even a reflex. It's like there is nothing, or like there is media opacity. It's completely hidden by some opacity. So similar to those conditions, in case of hyperopia, slow moving, width is wide but definitely not wide. Dull image is seen. So in that case, always put it to your hand +7 and -7, do the refraction. We don't know that it's myopic, so we always choose uh, two lenses in our hand and do the refraction. So higher plus, they will bring back reflex in your eyes. Okay. The oblique retinal reflex is not coordinated with your retinoscopic strix, but oblique to either against or motion. In this case, rotate the strix, reflex and meridian and neutralizes. Appears pattern is cylindrical refraction, oblique refraction. First neutralize the meridian and then see. Whenever you throw the strix, something like that, vertical, but the reflex comes like oblique, because reflex follows the patient's eye refractive error is central important. So that's why in that case just turn your retinoscope streak at same as the reflex. At that point you see the reflex become more thinner and more brighter, and then you know that you are in the correct axis. So it's central important to see oblique retinal reflex. because reflex always follow patient's eye refractive status. It doesn't follow that you throw it vertically, the reflex should come vertically. It doesn't happen like that. Okay. Scissor reflex, the old good scissor reflex, because scissor reflex, you have to understand, scissor reflex, it's about keratoconus, it's not about keratoconus. Okay. Scissor reflex, yes, one of the signs of keratoconus, but scissor reflex comes when cornea is distorted because of the nebular opacity, because of other opacity, macular opacity. So you must closely examine the cornea, is central important, and sometimes even opacity of the lens, you get confused with the scissor reflex. So it's very important, scissor reflex, you examine the cornea and the lens, the optical component. So, and then another thing, definitely you put your back of the head keratoconus is one of the there may be chance. And another point which is very important, neutralization reached first as a center other people, and then minus is necessary. So do neutralization, the central reflex. Okay. In summary, so instrument objective retinoscopy objectively measure refraction, and retinoscope reflecting self-illuminating, and there are a lot of things that we can say. But basically, optical principle is based on the far point of an eye and the peephole of the retinoscope, which is peephole of the retinoscope is, yeah, what if knife is and far point is focused, and then you have to understand Foucault's principle. Okay. So you have to understand this point, speed, brightness, direction, width, these all things literally saves your life when you are doing retinoscope. Okay. So finally, all are good books. This is great book to start as a bioptometry student. God, this, I don't know what to say. This is the only book that cannot be replaced in optometry, or what I can say. I don't know. Clinical refraction is a very good book, and everyone should read. And this is good book also. Okay, so I think till then, bye bye.